Hello everyone. Today in this video I will tell you how to find out differentiation of x raised to the power n where n belongs to R and e raised to the power x using first principle. First of all, let's see what is the definition and formula for finding derivative of a function using first principle. Let y equal fx be a function given to us. Its first derivative is the rate of change of y with respect to x, which is defined by dy over dx equals limit h tends to 0 fx plus h minus fx upon h. It is also denoted by f dash x. So we will find out the value of this limit, and it is the derivative of the function, and it is known as the differentiation of a function using first principle. Let's take the example, and with the help of the example we will uh, see the steps for finding derivative of the function. Function is fx equals x raised to the power n, where n belongs to R. So what is the first step? First step is we will write down the formula. Formula is f dash x equals limit h tends to 0 f x plus h minus fx upon h. What is the second step? We will find out the value of fx plus h. Fx is already given to us. Find out fx plus h. And fx is x raised to the power n. So fx plus h would be x plus h raised to the power n. Replace x by x plus h. That's it. Now substitute the value in the formula. F dash x equals limit h tends to 0 fx plus h is x plus h raised to the power n minus x raised to the power n upon h. Now, in the next step, we can add and subtract x in the denominator. We can write it as x plus h minus x. Adding and subtracting x in denominator. Now let x plus h equals y. As h tends to 0, imply x tends to y. Substitute this value over here. Limit, it will become y tends to x, and it will become y raised to the power n minus x raised to the power n upon y minus x. And this will become n into x raised to the power n minus 1. Why? Because we know that limit x tends to a, x raised to the power n minus a raised to the power n upon x minus a is equal to n into a raised to the power n minus 1. And here we can see in place of x we have y, in place of a we have x. So using this formula we can find its value. We can also find its value using binomial theorem. Second method, we can find out, we can simplify it in binomial theorem. We know that a plus b raised to the power n equals nc0 a raised to the power n plus nc1 a raised to the power n minus 1 into b plus nc2 a raised to the power n minus 2 into b square, and so on. We have ncn b raised to the power n. Using this formula, we can find its value. We know nc0 is 1, nc1 is n, and so on, its value is also 1. Substituting the value, limit h tends to 0, nc0 x raised to the power n plus nc1 x raised to the power n minus 1 into h, nc2 x raised to the power n minus 2 into h square, and so on, plus ncn h raised to the power n and minus x raised to the power n as it is, whole divided by h. This will be equal to limit h tends to 0, because we know that nc0 is 1. It will become x raised to the power n plus nc1 is n, x raised to the power n minus 1 into h, plus, and so on, it is again 1, h raised to the power n minus, this will be as it is, x raised to the power n upon h. This will cancel out. Then taking h common, it will become n into x raised to the power n minus 1 plus the second step was nc2 x raised to the power n minus 2 h square. It will be nc2 x raised to the power n minus 2 into h, and so on. It will become h raised to the power n minus 1 whole divided by h. H will cancel out. H will cancel out. And then substitute the value of limit. H is here, it will become 0. It will also become 0, only one term will left. This H will cancel out and only this will be there, n into x raised to the power n minus 1. So this is the derivative of x raised to the power n. Using first principle, we have calculated it. Next example, find the derivative of e raised to the power x using first principle. What is the first step? We will write down the formula. Limit h tends to 0, fx plus h minus fx upon h. Now find the value of fx plus h. Limit h tends to 0, because fx is e raised to the power x, fx plus h will be e raised to the power x plus h. That is simply e raised to the power x into e raised to the power h. Substitute the value. It will be e raised to the power x into e raised to the power h minus fx is e raised to the power x upon h. Taking e raised to the power x common, e raised to the power h minus 1 upon h. We can write it as e raised to the power x into limit h tends to 0, e raised to the power h minus 1 upon h. And we know that its value is 1. It is the formula using the concept of limit. So derivative of e raised to the power x is equal to e raised to the power x. Now, how to find out derivative of x cube minus 27 using first principle? So what are the steps? First step is we will write down f dash x equals limit h tends to 0, f x plus h minus fx upon h. In the second step, we will substitute the value of fx and fx plus h. Fx is x cube minus 27. So fx will be x plus h minus 27. Solving this, a plus b whole cube using the identity, we can write the value a cube plus b cube plus 3a square b plus 3ab square on minus 27. Substitute over here. Limit h tends to 0. Fx plus h will be x cube plus h cube plus 3x square h plus 3x h square minus and minus 27. And what is the value of fx? Minus x cube minus 27 whole divided by h. Now simplifying this, limit h tends to 0, x cube plus h cube plus 3x square h plus 3x h square minus 27 on simplifying the bracket x cube plus 27 whole divided by h. The next step, we will write down limit h tends to 0. This will cancel out, taking h common, and this will also cancel out. H square plus 3x square plus 3xh upon h. On calculating the value of this, limit of this, it will become 0. This is 0. This is again 0. Only 3x square will be there. So derivative of x cube minus 27 equals 3x square.